So in Chapter 8, Section 3, we're going to combine what we know about right triangles to do some solving of them. So by the end of this lesson, you should be able to use our trig ratios to find angle measures and then to solve some real problems. So for this first one, we're going to use trig ratios and figure out which angle is angle A. So they give us two angles here. They give us angle 1 and angle 2, but we know that the cosine of angle A is 24/25. So let's take a look at angle 1. If we take the cosine of angle 1, and remember, cosine is adjacent divided by hypotenuse. So my adjacent side is the one right next to it, 1.4, divided by my hypotenuse, which is across from the right angle. And if you do 1.4 divided by 5, you get 0.28. Now we want to compare that to this ratio up here. 24/25 is 0.96. So angle 1 is definitely not angle A. So let's prove that angle 2 is. So if we take a look at angle 2 and find the cosine of angle 2, we take the adjacent, which is 4.8, divided by the hypotenuse, which is 5. And 4.8 divided by 5 gives you 0.96, which is this ratio. So angle 2 is angle A. So remember in the last lesson we learned that when you take the sine of an angle measure, you end up with a ratio of side lengths. So angle measure, you get a ratio of lengths. So in this triangle here, because we took sine, and sine is opposite over hypotenuse, our triangle could have looked a million different ways. If this one was 30 degrees, opposite would have been this guy, and hypotenuse would have been this guy. So we could have had any combination that gives us 0.5. It could have been 5 and 10. It could have been 15 and 30. Anything that simplifies to 1/2 works for this. But now we're going to kind of go backwards. If we know that our ratio, or that the sine of an angle is 0.5, we can go backwards and tell what the angle measure is. So we're going to do inverse trig functions today. And they look like this. Sine, cosine, and tangent with a little -1 kind of as the exponent. And what it's saying is we want to go backwards. I know that this is the ratio of side lengths. Ratio of side length. And I'm going to find the degree. So find the angle measure. So if you know the sine, the cosine, or tangent, so remember these are all ratios, you can use the inverse trig function to find the measure of the angle. And then here are your inverse trig functions. And it's kind of like undoing it. If I know that a side ratio of angle A is x, then I can do the inverse sine of that side length and find the measure of my angle. Same thing works for cosine, and same thing works for tangent. So let's just type some in our calculator. Remember, I'm telling you that there's a ratio of, in this case, because it's cosine, it's the ratio of adjacent and hypotenuse gave me 0.87. So I want to know what angle measure will do that. So all you got to do is type it in your calculator. And if you go to your calculator where you have your sine, cosine, and tangent, right above it will have the inverse of each of these. So you got to click the second button, hit cosine of -1, and then type in 0.87. And you end up with 29.5413605. But they tell us to round to the nearest degree. So this is about 30 degrees that will give us that ratio. So again, remember for this one, it's telling us that there's a ratio between the opposite and the hypotenuse that gives us 0.85. So make sure that when you type this in your calculator, you can get out the same degree that I do. About 58 degrees will give us that. And then finally the last one, the inverse tangent of 0.71 gives us about 35 degrees. So using measures to find unknown angles or side lengths is known as solving a triangle. So to solve a right triangle, you need to know at least 2 side lengths or 1 side length and an acute angle measure, not the 90 degree. We have to know that it's a 90 degree to do any of this stuff that we're about to do, but we have to know one of the other angles, because then, you know, we can use the third angle theorem, and then we can do inverse trig functions to solve for some sides. So find the 3 unknown measures, round lengths to the nearest hundredth, and angle measures to the nearest degree. So when I look at this triangle, first thing I want to double check, is it a right triangle? If it's not, we can't do any of this stuff. But because it is, I need to find ST. That's one of my unknown lengths. So because I have 2 lengths of this triangle, I'm going to use Pythagorean Theorem. A squared plus b squared equals c squared. And this is going to be one of my legs. So let's plug in 5 for this. We'll solve for b. 5.7 here. Oops, that should be plus. And 5.7 squared is 32.49. I subtract 25, we get that b squared is 7.49. And take the square root, and you get, and because we're rounded to the nearest hundredth, we want 2 decimal places, 2.74. So this is 2.74 up here. So we'll name this ST. So there's one of my unknowns. Now my other 2 unknowns are the angle measures. So the angle measure of R and the angle measure of T. And this is where it doesn't really matter what you do next. So the angle measure of R, let's take a look at the sides that they gave us in the problem. Just in case we messed up on this one, we don't want to use this one unless we have to. So they gave me the side closest to it, which is the adjacent, and they gave me the hypotenuse. So think back to SOHCAHTOA. Which one deals with adjacent and hypotenuse? And because that's cosine, I'm going to use the inverse cosine. And I want my ratio to be this 5 over 5.7, and that's going to tell me the angle measure of R. So you type that into your calculator, the inverse cosine of 5 divided by 5.7, and you end up with, because we're rounding to the nearest degree, about 29 degrees. So that's what this is up here. Now you could go through with angle T and do the same thing, use opposite over hypotenuse and use the sine, or think back to what we know about triangles. They have to add up to 180 degrees. So if I have 2 angles, like I do here, angle T is just going to be 180 minus the 90, because that's what angle S is, minus the 29 that we just found, and you end up with 61 degrees. So now we know absolutely everything about this triangle here. So let's do one where it's on the coordinate plane. The steps are exactly the same, except they gave us points first rather than drawing us out a triangle. So let's draw the triangle out. We have point P at -3, 3, Q at 2, 3, and R at -3, 4. Find the side lengths to the nearest hundredth and the angle measures to the nearest degree. So some of these side lengths are pretty easy, like PQ, all we gotta do is count. 1, 2, 3, 4, 5. And then PR, again, all we gotta do is count. 1, 2, 3, 4, 5, 6, 7. And then RQ, we can use Pythagorean Theorem to find. So 5 squared plus 7 squared going to give us that c squared. 25 plus 49, you end up with 74. And we want to round it to the nearest hundredth, so 2 decimal places. So when you take the square root of that, you end up with about 8.60 for RQ. So this is 5, this is 7, 8.6. So now we got to find the angle measures. So the first one that I'm looking at is this angle P here. And because we know what we know about slopes, I know the angle P has to be 90 degrees. And that's because PQ is perpendicular to PR. We can prove that the slope here is 0, the slope here is undefined. So you know horizontal and vertical lines are always perpendicular. So that one's pretty easy. Now you got to choose one of the other ones, either Q or R, and it doesn't really matter, and use our inverse trig functions. So let's choose R down here. So it doesn't matter what side lengths you use. Let's use these nice pretty numbers. So my opposite and my adjacent. So go back to SOHCAHTOA. What trig function uses opposite and adjacent? Well, it's tangent. So because I know the ratio here, I want the inverse of the tangent function. So it's the opposite, which is 5, over my adjacent, which is 7, and that's going to tell me my angle measure. So then you just type it in your calculator. The inverse tangent of 5/7, and it spits out a nice pretty angle. And because we want to round it to the nearest degree, I get like 35.5, so we'll round it to 36 degrees. So that's this angle down here is 36 degrees. We know this one's a right angle. So then we can quickly solve for angle Q. It's going to be 180 minus 90 minus 36. So you end up with that one being 54 degrees. So we have solved for every part of this triangle when we were only given the points of the triangle. Last problem. The steepness of a road is often expressed in percent grade. If a road has a steepness, or has a 31.5% grade, that means that it rises 31.5 feet over a horizontal distance of 100 feet. Because remember, percent is basically divided by 100. So this right here makes an angle. We're going to find that angle in this next problem. So if you have a highway sign that warns a section of road ahead has a 7% grade, to the nearest degree, what angle does the road make with a horizontal line? So remember, 7% means 7 over 100. That's the ratio. You can draw yourself a nice little picture. Over 100, only up 7. So we're looking for a nice tiny angle right here that this makes. So because we want to find this angle, we need to use inverse trig functions. We got to look at what we are given. We are given the opposite and the adjacent. So SOHCAHTOA, opposite and adjacent, we're going to be using the inverse trig function tangent. So we want the inverse tangent of my opposite, which is 7, divided by my adjacent, which is 100. And if you type that into your calculator, you get right around 4 degrees, which makes sense when you think about it. It's going to be a pretty tiny angle because you're not rising up much for as much as you're running over. So you should be able to use the trig ratios and inverse trig ratios to find angle measures and right triangles and to solve real problems. Make sure you write down any questions you have and we can go over them in class. Have a good night.